Good morning everyone. In today's lesson we will talk about another central difference formula, that is Gauss's backward interpolation formula. In the previous lesson we had seen Gauss's forward interpolation formula, and in today's lesson we will discuss the Gauss's backward interpolation formula. Both are central difference formulas. So let's see what's the formula for Gauss's backward interpolation formula. Y is equal to y0 plus u del y minus 1. Here it's the difference. If you remember Gauss's forward formula, then here we had y0, but in this formula we have y minus 1 plus u plus 1 dot u divided by factorial 2. This is another difference. In the forward formula we had u dot u minus 1, but in backward formula we have u plus 1 dot u divided by factorial 2 del 2 y minus 1. The next one is u plus 1 u minus 1 by factorial 3 del 3 y minus 2. So the pattern is similar like in the Gauss's forward formula. Here also we have a pattern, and let me write the next term for you so that you can recognize the pattern. You can see we have y0 first term, then again in the two terms y minus 1 is repeated with the high powers of del. Then in the next two terms y minus 2 will be repeated, and the next two terms y minus 3 will be repeated, and so on. In the numerator, if you can see, with u in the next term we have added u plus 1. With this term in the next we have added u minus 1. So one time we are adding u plus 1 and then we are adding u minus 1. So in the next term we will add u plus 2, right, and so on. In the denominator we can see this is factorial 1, that's 1, it's factorial 2, it's factorial 3. In the next term we should have factorial 4. So let me write the next term for you. The numerator we'll add u plus 2. So this will be u plus 2, and the previous part, that is u minus 1, divided by the factorial will increase from 3 to 4. The del, power of del will increase from 3 to 4. And this is y minus 2, this will be same y minus 2. So this is the next term for this backward formula. Let me write one more term. So just to add one more term, we will take this numerator and we'll add u minus 2 in this. So now this will be u plus 2, u plus 1, u minus 1 and u minus 2. The denominator will be factorial 5 incremented, del will be factorial 5 incremented, and now as we can see that we have y minus 2 two times in the formula, then this will also increase, and now this will be y minus 3. So this is the next term. So in this way we can add as many terms as we want. So let's discuss this formula with the help of an example, and before going to the example, let's see what is u here. As in all the cases, u is equal to x dash, that is the quotient value, minus x0, that is the initial value. Here the initial value will behave the initial value will be the origin value, the central value, and h is the equal interval. So let's see, this is the example where we have given the year and the population of a town in thousands. So for x values we have 1931. In the year 1931 the population of the town was 15,000. In the year 1941 the population of the town was 20. In 1951 it was 27,000. In 1961 it's 39,000, and in 1971 it's 52,000. The first thing we need to notice that there should be equal intervals. So we have equal intervals of 10 years in each data value. Now let's notice what is the quotient value. The quotient value is x dash, that is 1946. So let's calculate u first for our question. So u will be equal to the quotient value 1946 minus the x0, that is the origin value. As we have seen that with the central difference we always take the center value as our origin value. So here we have, let's say we have this is as x1, this is x2, or let's call it x0. Let's start x0, x1, x2, x3 and x4. This is in the forward difference formula, but here we will not write x0 from here because we are taking central difference. So we'll take the center value as our x0, then we'll increment, this will be x1, this will be x2, and on the left hand side we'll decrement, this will be x minus 1, and this will be x minus 2. So what is x0? So the x0 is 1951. So we have this as 1951. This whole is divided by the interval, that is 10 years, 1931 and 1941. This is 10 years. So the interval is 10 years. So this is coming to be minus of 5 upon 10. Or we can say this is minus of 0.2. So minus of 5 upon 10, this is coming minus of 0.2. So we have u as minus of 0.2. Now let's construct the table for the calculation, as we need these values y0, del y minus 1, del 2y minus 1, and so on. So let's construct this table. As we know that this is x0, this is x1, this is x2, this is x minus 1, this is x minus 2. Then this will be y0, this is y1, y2, this will be y minus 1, and this will be y minus 2. So we need to calculate del. So this will be del y minus 2, which is always equal to y minus 1 minus y minus 2. This is 20 minus 15 coming to be 5, right? So this is coming 5. Let me write 5 here in place of this. So del y minus 2 is coming 5. Next is del y minus 1. So this is del y minus 1 will be y0. This will be y0 minus y minus 1. Forward del definition, using the forward del definition. So what is y0? This is 27 minus 20 comes to be 7. So let me write here del y minus 1 as equal to 7. Similarly, this will be del y0, and this is 39 minus 27. So this is 39 minus 27 comes to be 12. Then it will be del y1, and this is 52 minus 39. This is coming 13, 1, 3. So this is the first del. Let's calculate the second del. This is del 2 y minus 2. Now what is del 2 y minus 2? This will be obviously del y minus 1 minus del y minus 2. Del y minus 1 is 7. So this is 7 minus del y minus 2 is 5. This is 5. This is equal to 2. So let me write 2 here in place of all this. So this is coming 2. What is next? Next will be del 2 y minus 1. This will be 12 minus 7. So 12 minus 7 will be 5. Next is del 2 y 0. So this del 2 y0 will be 13 minus 12, that is coming 1. The next column, this will be del 3 y minus 2. So what is del 3 y minus 2? This is 5 minus 2 coming to be 3. Next is del 3 y minus 1. This is 1 minus 5 coming minus of 4. And in the last column, this is del 4 y minus 2, and this is coming minus 4 minus 3. This is minus of 7. So this is how we can construct the table. Now let me highlight that what values we will be needing from this table. In the formula we need y0, so we need this y0. Then we need del y minus 1, so we need this del y minus 1. Then we need again del 2 y minus 1, so this is del 2 y minus 1. Then we need del 2 y minus del 3 y minus 2, and then this is del 4 y minus 2. So we can see we have a zigzag pattern, up, down, and down. Right, in the Gauss's forward, we just had opposite. First we had down, then up, down, up. And this is the opposite pattern, up, down, up, down. So these are the values that we will be requiring. Let me keep these values safe somewhere. So let me write this del 4 y minus 2 is equal to minus 7. Then del 3 y minus 2 is equal to 3. Let me erase these values. Okay, then I have del 2 y minus 1, this is 5, and then I need this del y minus 1, and this del y minus 1 is 7, so this is 7, and lastly this is y0. So y0 is 27 in our case. So this is y0 coming to be 27, right? So I have kept all the values safe. I have the value of u, I have the values of y. Now let me rewrite the formula according to the question. Now let me rewrite the terms according to the question. So let me write how many terms we'll be requiring. We'll be requiring terms till del 4 y minus 2. So we need one more term in this. So y is equal to here y0 plus u del y minus 1 plus u plus 1 u by factorial 2 del 2 y minus 1 plus this is u plus 1 u minus 1 by factorial 3, and this is del 3y minus 2. We need one more term, so let me write the next term. The next term will be u plus 2 u plus 1 u minus 1 divided by factorial 4, and this is del 4 y minus 2. So this is the last value we have, del 4 y minus 2. So we'll use till this term. Now let me substitute all these value into the formula, and on substituting y0, what is the y0? This is 27 plus what is u? U is minus 0.2. What is del y minus 1? This is del y minus 1 is 7. Then plus u plus 1. What is u? Minus 0.2 plus 1, and this is minus 0.2 whole divided by factorial 3. This is del 2y minus 1. This is del 2y minus 1 is 5. Right. Plus the next will be minus 0.2 plus 1 minus 0.2 minus 0.2 minus 1 whole divided by factorial 3, and this is del 3y minus 2. This is del 3y minus 2 is 3. So I'm taking 3 here. And the last term, obviously the last term will be minus 0.2 plus 2, then minus 0.2 plus 1, and then minus 0.2 minus 0.2 minus 1 whole divided by factorial 4, and this is multiplied by del 4y minus 2. So del 4y minus 2 is minus of 7. So now we need the scientific calculator and perform this calculation. Again, a tip that you should take care of all these brackets, when to divide, use a BODMAS technique even in the scientific calculator, and obtain the desired result for this. So let me see what is the desired result for this question, that is coming to be 22.89. So we have 22.89 as our final result, that is the population of the town in thousands, 22.89 for the year 1946. So we have approximated the population in the year 1946 for that particular town to be 22.89 thousands. So this was the Gauss's backward interpolation formula. I hope you have understood this. In the coming lessons, we will be talking about more central difference formulas. Thank you so much.